I think she was doing it a different way, and I don't know what different way she was doing it by.
Interesting.
Yeah.
Well, you could always do like the Dropbox or the AirDrop, which is like you can send it
Yeah.
just right away.
Apple is just enough different than Samsung phones that it's hard for me to know exactly what your options are when you take a picture. But I'll get it figured out at some point. Yeah, the picture that this other person sent me looked like it was in small image. It was very hard to read, wasn't very high resolution. And I've noticed that that's what you get when you send an Apple with an iPhone. When you send an image by small image, you can't read it. So you have to send them by large images for sure. All right, let's look at this. Proving triangle congruencies. All right. And they don't need a two-column proof here, I'm assuming. They just want your strategy for proving it?
I'm sure they wanted two-column proof.
What's the very top of that thing say? Proofs are what?
Good food.
Proofs are good food?
Yeah. Yeah.
It's like they're saying that proofs are like vegetables and fruit, huh? All right. Well, let's do this a couple of ways. In order to do a two-column proof, you need to actually be able to figure out how you're going to prove it anyway. Okay? So let's go through the logic of it, and then maybe we can go through the logic of all three of these problems, and then if we have time, which is not likely, we can go back and do two-column proofs on one of them.
Okay.
Okay? So N is the midpoint of BO. What does that allow me to do? Start marking up this picture. If N is the midpoint of BO, that means BN is the same as NO, right? So I can do that immediately. Okay? And then it says BI is parallel to GO. So let's do this. What does that mean regarding some of these angles? Do we know anything? Based on the fact that we're now looking at two parallel lines and a couple of transversals. In other words, BO is a transversal and so is IG. Okay? And that means you can tell something about these angles. If I label these angles 1, 2, 3, 4, 5, 6. What do you know about some of those angles based on the parallel lines?
That they're like in
which ones are equal?
Oh, 5 and 1.
If I drew two parallel lines and a transversal, this angle is equal to that angle, right? Okay. What you kind of need to do in your head is rotate this image. In other words, your parallel lines are not always going to be horizontal. In this case, they're closer to vertical. But IG is still a transversal. Okay. So what does that mean about angle 1 and angle 5?
That they're the same.
Yeah, they're congruent. Okay, so I can do this. That angle is the same as that angle. How about angle 2 and angle 6?
That they're also the same.
For the same reason. That's alternate interior angles between parallel lines. So I'm going to put a double thing there and a double thing here. And what do we know about 3 and 4?
They're the same because
Why? They're vertical.
vertical.
Vertical angles are always the same. So, which hypothesis is going to be used to prove that one triangle is congruent to the other?
Angle, side angle.
Yeah, we could use that one. In other words, we don't even care about that one there. We can not even know that. Merely the fact that we have angle, side, angle equals angle, side, angle. That's all we need to prove congruency. Okay? So, in the two-column proof, we wouldn't even need to say that I was equal to G. As long as we say B is equal to O, and those vertical angles are equal to one another, now we can jump straight to the conclusion that the triangles are congruent due to angle, side, angle.
Okay.
All right, let's cover all of these because some of these congruent problems can be a little tricky. So by far the most important thing is to be able to understand how to prove. That's actually a lot more important than being able to do an official two-column proof. We might have time to do one of these, but I think you can kind of see that the two-column proof isn't going to be that tough once you figure out the steps that we're using to prove this. Okay, let me label this B-L-I-N. Li equals Ni. So immediately start marking up your figure like that.
Okay.
Gi congruent to Bi. Gi and Bi. So this distance here is equal to this distance here. I'll even put a double hash mark like that. Okay? Notice that I cannot put a double hash mark right there because that would indicate BL.
Okay.
Okay? So you just have to know that BI is equal to GI, and it's hard to mark up the figure to show that. And we're trying to prove that LIG is congruent to NIB. All right. So, one thing that's quite useful is to separate them. If it gives you a problem having them together, separate them. Okay, and I'll show you why that helps, particularly in this problem. And this is I also, and that's L, and that's G. And now we can label stuff. We can label that side is equal to that side. And furthermore, we know this side is equal to that side, right? I said Ni is congruent to Li. Okay?
Yeah.
We only need one more piece of information. In other words, we have two sides that are equal. Is there any way we can prove that the included angles are equal? In other words, it doesn't do any good to prove B is equal to G. That's not a proof for congruency. If I could somehow prove that I is equal to I, oh, they're both I.
Yeah.
What
But they
geometric thing proves that I is equal to I? Which
Uh, mm,
the reflexive.
oh yeah.
Okay? It's a hard one to remember. I've always had trouble remembering which property proves that something is equal to itself because it seems so stupid that you have to do it.
Yeah.
Why should you have to prove something is equal to itself? And that's partly what's so frustrating about proofs, is that you
Yeah.
have to do that. But here we would need a statement in the two-column proof that I is equal to itself based on the reflexive property, algebraic property. Then you have this triangle is congruent to this triangle based on what?
SAS.
Yeah, side angle side. Okay, let's take a look at the third one real quick. See if we can get it done in time to go through and do at least one two-column proof on these. But I think you can see where separating them actually helped quite a bit, did it not?
It helped a lot.
Yeah, and part of the reason was I didn't have a really good way on the single photo or on the single diagram of showing that BI is equal to GI. And they're both made up of two line segments.
Yeah.
So here we have H, W, M.
The bottom one is A.
And that must be A, huh?
Yeah.
Okay. HW is equal to MW. AH is equal to AM. So tell me how we're going to prove that this triangle is congruent to this triangle.
Well, W and A is congruent to itself.
Once again, by the reflexive property. So I'll put 3 dashes through that. And now why are the two triangles congruent?
Side, side, side.
Yes. Okay. Let's do the two-column proof. Sure. Well, shall we start at the top, 23?
Sure.
Okay. So we got statement, reason. What's the first statement?
The given.
Okay, so N is midpoint of BO, line segment BO, and that BI is parallel to GO. That's the given. What's the next row? Statement. What's the next statement? If you'll remember right, we've got the parallel lines. What's important?
So would it be alternate exterior, or it would be
Here.
I and G?
In other words, 1 is equal to 2 because they're alternate interior. Notice what the difference is. These are alternate interior down at the bottom because they're inside the parallel lines. And they're alternate because they're on opposite sides of the transversal. Okay? Why are these called alternate exterior?
Because they're outside
the parallel lines. They're still alternate on either side of the transversal, but that's the difference between alternate interior and alternate exterior. And these two angles that we're talking about are inside the parallel lines. Okay? So let's say that the next statement we're going to give is what?
That I and angle I and angle G are congruent.
Yeah, and let me just do it like this rather than using three-letter designations. Is that okay?
Yeah.
For you? Based on alternate interior angles of parallel lines. Okay? What else? What's the next statement going to be?
Angle B and angle O are congruent.
Yes, line segment BN is congruent to line segment NO because of what? The midpoint theorem. Midpoint theorem saying that when something is bisected, it's, well, when you have a midpoint, the midpoint means BN is equal to NO by the fact that the midpoint theorem says that N is the midpoint of BO. That means that BN is equal to NO.
Mm-hmm.
Okay. What's the fourth thing? So at this point we have angle and one side. In other words, let me draw it on the proof or on the picture, excuse me. In other words, we know that's equal to that, and we've proven that that's equal to that. What else do we know?
We know that
Think vertical angles. Vertical angles are always a really good place to start. I actually should have started there. My second statement should have been angle BNI is equal to angle GNO. Angle BNI congruent to angle GNO. Why?
because of vertical angle.
That's all you need to write, vertical angles. And finally, enough?
Yeah, I think.
By which theorem can we say?
Angle side, side angle.
Angle, side. And that's all we have. We have angle, side. There is a provision on angle, side that I'm not sure you're aware of, and that is that it has to be a non-included side and it has to be the same non-included side. Okay? For example, let me just talk about this because I just discovered this yesterday when I had another honors geometry student from Chatfield who was given the following problem. Let's see if I can remember it. That angle was equal to that angle. That angle was equal to this angle. And this side was equal to that side. Are those two triangles congruent?
No.
They are not. Well, you don't know that they are. Why not? It's angle, side. Angle, side.
Because they have to be like
It's not the same corresponding side is the problem.
Yeah.
And I came up with a really good example to prove it. If I had this triangle, a 2, 3, 4 triangle like that, and over here I'm going to make it similar. Okay, so I'm going to make it 4, 6, 8. Are you familiar with similar triangles?
We haven't learned them, but I know what they are.
Okay, good. Similar triangles mean they have the same 3 angles.
Yeah.
Okay. Well, they told us that two of the angles are the same, so we certainly know that the third angle is the same.
Mm-hmm.
But clearly, in the picture I've drawn, the triangle on the right is twice as big as the triangle on the left. Every corresponding side is twice as big, right?
Yeah.
Okay, and so that means they're clearly not congruent, because if there's one thing congruent means, all three sides are the same.
Yeah.
No matter how you prove congruency, once you prove it, all three sides have to be the same. Well,
Mm-hmm.
clearly all three sides are not the same here. So these triangles are definitely not congruent, and yet this is still angle, angle, side of 4, and this is angle, angle, side of 4. So it's not just angle, angle, side that has to be proven. You have to make sure that that side is the corresponding side. Now, notice what I had to do angle, angle, side on the left. I had to go clockwise, right?
Mm-hmm.
Notice what I had to do on the left. I had to go counterclockwise. I mean on the right. In other words, angle, angle, side is counterclockwise. Whereas over here, angle, angle, side is clockwise. So that's one method you can kind of use to tell whether angle, angle, side is going to work or not, is to make sure that to get the angle, angle, side, you have to go the same rotation. You have to go clockwise or counterclockwise on both.
Mm-hmm. Yeah.
Otherwise, you can end up with this situation here where this side of 4 is not the same, it's not the corresponding side to that side. Over in this triangle, it's the smallest side. Over here, the corresponding side would be 2.
Yeah.
So that's what we would need to be equal, would be the 2 and the 4. All right, let's see. On proofs, bottom one was pretty easy, right?
Mm-hmm.
That's going to be like a 2-statement proof. You got your
Yeah.
givens. You got your statement 2 is WA is going to be equal to itself based on the reflexive property. And then statement 3 is going to say congruent because side, side, side.
Yeah.
Okay. On number 2, a 2-column proof. It's pretty easy. The givens are going to be what's there. And what we're going to be able to say is that the short side of these two triangles are equal to one another. That's part of the given. And angle I is equal to itself by, again, the reflexive property. And now all of a sudden you have side, angle, side for both triangles. So the congruence is going to be proved by SAS.
Okay.
Okay. Well, that's not bad. I didn't think we'd have time to even get to the 2-column proofs, but 2-column proofs aren't so bad once you do a few of them and you remember things like the reflexive property and the transitive property and all of those properties. Those are harder to remember than the conditions that require congruency. You know, the SSS, SAS, and notice that SSA does not prove congruency. It does if the angle is 90 degrees or greater, although I've never seen a geometry book state that. But it's true. If you have an obtuse triangle, and I have an obtuse triangle, and I know that side's equal to that side, and that side's equal to that side. If this angle is equal to that angle, that does prove congruency, even though it's side-side angle in both cases. Because this angle is obtuse, and this angle is obtuse, we know that they're congruent, although now I understand why they don't have a theorem in the book for that. It's got to be the included angle between the two known sides has to be obtuse or greater. And you rarely get that defined. Anyway, Allie, I'm sorry I got to go. I got a 4:30, so I'm glad we got through all three of these.
Thank you very much.
You're welcome. Talk to you next week.
Bye.
Bye-bye.